So last class, previous what we discussed is all about the entity, attributes, relationships. Then we talk about the constants with the cardinality ratio. Then it comes up with the participation constants, how the total and partial participation works. So this has been flow of what the ER diagram what we started in previous two classes, in previous 2 or 3 classes, where I am going to flow how the entity works, So now I'll show again, come back with the procedure of how the process goes, how the process has been goes with the entity relationship. Then I may think of going with bringing up a recursive relationship with the weak entity concepts. Then I comes with a generalization, then aggregation. Then I start with my beautiful writing ER diagram for a real-time application, Okay. So as I told, we have an entity what tells that object in the real world with an independent existence, So faculty, if I consider as an entity in a database of university or a college, then faculty ID is what you call as a key to uniquely identify entity in entity set, Then we have name, which can be divided into first name, last name, and middle name. Okay, so middle name. Then there is a derived attribute that defines age based on date of birth. Then we have a multivariate attribute, that is phone number, which has then I going with the relationship faculty teaches subjects, right? So subject as subject code, SID, and subject type is odd or even. Then subject name that can be defined. So here we told about entity with the independent existence, object it has independent existence. Then we have an entity called faculty with attributes, single, stored, and simple attribute, that is faculty ID. Then I have name, which is split into multiple attributes. So split attributes to attributes itself, that is called composite attribute. Then I have multivariate attribute with the attribute which takes more than one value, that is multivariate attribute, that is phone number. Then I have another entity, that is subjects with key as to identify, then subject type, then subject name, right? Subject name we have. So here the relationship with the diamond symbol represents, I told there's 2 types of relationship, one is binary relationship, another one is ternary relationship. So here the faculty teaches subjects. So it is binary relationship because it has only 2 entities. If I go for 3 entities, then I think of going with a ternary relationship, So faculty teaches subjects, Okay. So teaches is a role represents the relationship with the diamond symbol between 2 entities, Here the teachers define the role between 2 entities, So this is what the relationship with the binary set of entities. So now, as I told, I want you to go for constants. Okay. So constants, I have told there is a 1-to-1, 1-to-many, many-to-many, many-to-one. So here one faculty teaches many subjects. Right? One faculty teaches many subjects. Then I want to go for a participation constant, that is total or a partial. So here we have a faculties. For example, if I consider department, so in department we have so many faculties, but I am consideration is only one faculty, that is me. So here we have a set of faculties, but I am going for only one faculty. That is one faculty teaching, myself teaching many subjects, myself teaching and many subjects, right? I'm teaching many subjects. So that's what I'm covering, most of the subjects. So that's what I'm going to total participation. Then there is many faculties, but I'm picking only one faculty. The participation is partial. The participation is partial here. But here we have total participation because I'm covering most of the subjects which are matching to my criteria, that is total participation. So it's partial participation because the participation is only one faculty in a set of n faculties, This is what yesterday we talked about, the constants with total participation, partial participation. Then we comes with what we call as Cardinality ratio that defines 1 to 1, 1 to many, many to many, and many to 1. Like this we go have, right? So next, so this is what we discussed. So next I will go to an recursive relationship. Hope it's going on, right? So I feel about how the DBMS is going on, right? It's one of fantastic thing you people are think about how the DBMS is going for real-time applications. I'm talking about all the applications which is in around us. It is in around our area, right? So now recursive relationship. So hope you learn recursion in what I call as in a previous, what I call as in a fourth semester or in a second semester. If people start thinking about recursion, right? Recursion, calling itself, right? Recursion is nothing but a calling itself. So here we have in a DBMS, we have recursion to entity. Okay. So see here, so we have an employee. So we have an employee. Okay, employees, SSN and name. SSN and name. So it has calling itself. As I told, recursion is calling itself. So here calling the relationship, calling the same entity set. The relation is calling same entity set is called recursive relationship. So employee supervises. Employee supervises employees itself, right? So one employee supervises many employees. One employee supervises many employees. So calling same entity set is called recursive relationship, where the employee, so myself, employer, which is head of the department, so as an employee I supervises many employees of my department, right? So like that, one employee need to supervise many employees, right? Many employees, which is total participation in many side, because there's all the faculties are participating. But when I go for myself supervising and taking one of an employee from entire set, that become partial participation, thus becomes total participation. Because every employee is participating. So here see that. So one employee supervises many employees. One employee supervises many employees, right? Calling same entity set. Calling same entity is called recursive relationship. Okay. Then we have another example where I will define with course. So for example, we take a course of C++ or a C++. Okay, C++ required. So course ID, course name. So course ID, course name, So one course, for example, I want to learn machine learning. So machine learning is a course which required mathematics, which required numerical techniques, which required data structures, right? So machine learning requires most of the things as of basics of computer science, basis of and computer science. So my question arises is how many courses it requires. Machine learning requires n number of courses. If I want to learn the course called machine learning, I require to know about mathematics, I require to know about numerical techniques, I require to know about data structures, right? I require to know about automata because of string matching, string information need to understand with the grammars, right? That's what you required n number of subjects to learn a machine learning course, right? So one course called machine learning requires so requires many courses. So many courses. One machine learning requires many courses, where again we are learning about courses. So again one course required many courses, right? One course required many courses. So one pre requires many courses. One requires many courses, where I tell is a total participation and M side, and there is picking n number of courses in the consider of a B course or any semesters, but I am picking only one course that become partial participation. That become an partial participation. Partial participation it comes. Okay. So one course pre requires many courses. Pre requires many courses. Okay. So this is called an recursive relationship. This is called an recursive relationship. Okay. It's called an recursive relationship. Then, so this is what how the symbol is want to include to be in entity set. This want to include to be in entity ER diagram. While writing ER diagram, you want to learn about what you call as recursive relationship. That's what we learn. You will implement this in a ER diagram. In a ER diagram. Then we go with weak entity. You go with an weak entity. We go with an weak entity. So what is weak entity? We have seen strong entity. So if I tell a definition of strong entity, the entity which has its own key, entity which has its own key is called weak entity. Is called weak entity. Here, if I tell employ as entity, which has its own key, that is SSN. That is its SSN. So employee has its own key, that is his SSN as a key. It has own key. That's what it's a strong entity. It's a strong entity. Then we have name. Then we have each date of birth, right? Date of birth. Okay. So we have told strong entity. Now how to define weak entity? How to define an weak entity? Why it's called weak entity? Why I need to be called as a weak entity? The question arises, right? So weak entity is the entity which is depends on strong entity keys, So that is called weak entity. The entity which is depend on strong entity key. Key means key which identify uniquely entity. So the weak entity is completely depend on the strong entity with the key specified is called a weak entity. Is called an weak entity. So myself an employee of a particular organization or institution, right? Institution. So myself as a dependence. So I as an employee for an insurance purpose. Hope you know the particular all the whatever the employees working must have insurance, must have health insurance, right? Must have the health insurance that to be required is a most required, right? That's what each employee has health insurance for himself and for its dependents. So myself I have a dependents like my parents, my son, my wife. So they are the dependents I have. So how we identify my dependents? For example, myself employee with the SSN 777. So I need to identify you people. For example, any insurance company, maybe IFCO, Tokia, or Reliance, or any of the insurance provider need to check how many insurance provider for particular employees, right? So they need to check how many employees they are providing the insurance with the how many dependents, So myself an employee for a particular organization, they check with my SSN, so they identify Sharat Kumar as 5 dependents. Right? So based on my SSN, they identified. They do not have any unique keys to identification. They just have a name as a key. The dependents are completely depend on my ID, right? Because I am the employee working, so based on my SSN, my dependents are identified. My dependents are identified using my employee ID, that is 777. Right? Like that, we have like this. This is the way of representation and weak entity. This is the way of representation of a weak entity. Okay, this is the representation of weak entity. So this is a representation of weak entity with the double lines. So dependents. So it's a dependents with the dependents. So dependent as dependent name with a dependent name. That is dependent name. So dependent name as key called depends. That is weak entity as a key called partial key, not a primary key. It's a partial key it has. That is dependent name represented through dashed lines. When you want to represent the primary key, you want to define underline like this. But when you go for partial key, you want to define dashed lines because the keys belong to weak entity. The keys belong to weak entity, which is strongly depend on strong entity. That is SSN. So using my as an employee with the SSN as dependents. So myself as a dependent. So when you go for representation of weak entity, it must be double and it must be always many relationship, because always one employs many dependents. So this part must be always same. This must be always same, that it has representation of a weak entity. So employee has dependents. So one employee has many dependents. You want to represent double line for relationship and double line for rectangular entity. You want to represent rectangular entity with double lines, and with double lines for has and double lines for total participation. Must have total participation with a many relationship with what you call as double representation with the dashed lines for partial key. That is called an weak entity. So here dependence is completely depends on the strong entity called employee with SSN. That is employee as a unique key that's specified. To be specified. So employee SSN is identified the dependents. So myself SSN identify dependents with the double line, with the relationship double line, with the total participation, with the many, with the dashed line. That is called partial key. That has to be by weak entity. That has contained by weak entity. Weak entity is a key called partial key. Strong entity is a key called primary key. Like this it goes. Like this the weak entity is being called. Okay. So always depends strong entity. So completely identified by strong entity is called what you call as weak entity. This is the best example. There is one employers, many dependents. Like that. Another example I will give. So loan means bank provides loans. So loan number, loan type. Which type of loan you are taking? It may be home loan, it may be car loan, it may be agriculture loan with as, right? So loan has various types. Loan has loan number. So loan has payments. So myself, I have taken car loan, I have taken home loan. So I am paying EMI every month. right? I am paying EMI every month. So identify every month that I paid my how much amount I paid. We will check it out, right? Based on loan number, you identify how many payments have been done. So based on payments, you cannot identify loan. So based on loan key, you want to identify particular loan number taken by Dr. Sharat Kumar. So this is a car loan number is taken. This is the payments have been happened, right? So each may be our transaction ID, but based on loan number, we are going to identify the payments. We are going to identify the payments, right? That is payment number. Payment number is a partial key that identified the amount, that is other relationship, the amount, that is other entity with the attribute, that is amount for, because payment is so many payment number, that is transaction ID. What I call as amount as a other entity. So one loan has many payments. One loan has many payments. One loan has many payments, right? So based on loan number, I am going to identify how many payments have been done. How many payments have been done? How many payments have been done? So one loan has many payments. So based on loan number, you want to identify how many payments have done for particular loan, like home loan or a car loan. Based on loan number, we are going to identify this month of 24 months. For example, I want to take a loan for 24 months of 2 years, and you can see it out based on loan number. I have paid 10 months of EMI. Still 14 months are remaining. Based on payment number, you are not able to identify. So using this, you are going to identify what loan number, what my payment number is belong to which loan number, right? Based on loan number, I am going to identify how many payments have been happened. That's what the payment can be called as. In a bank database, payment can be called as weak entity, right? In a weak entity. If in bank database, if I consider bank provides or a bank or a branches provides loans as a payments, where payment can be called as a weak entity, because it's completely depend on loan number primary key. Depend on loan number primary key. This is the fantastic thing of a weak entity. Okay, so weak entity is a key called partial key, that is here P number. That's your P number, represented with double line for entity, total participation for relationship, with M as a participation constraints with a ratio of M. Then I comes with the relationship of diamond symbol with a double line, that is represents the weak entity. Okay, so this is about the weak entity that contains. So each database, when I write a ER diagram for various databases, make sure that you include weak entity. The weak entity, because the chapter goes such a way that it go on flows and apply to the real-time application like bank, where you need to specify the weak entity, because weak entity in a representation in relation to real-time application carries more marks through your exam, and also it represent well through real-time application like databases. Real-time application for Baker databases. For community database, you can write it as employee as dependents. For community database. For a bank database like this, for moving in a different entity, you need to identify. Right. So like this, we have a n numbers. Like this, we have a n numbers to be identified. Okay. So this is what the weak entity. This is what for weak entity. Then I will go with generalization. So because employees, if I consider an employee, so employee has teaching, non-teaching employees. If I go for companies, if I go for banks, there's a supervisor, right, who analyze. There's a managers, there's various insurance, various sections of the bank. Bank has insurance, different type of insurances. They provide what is called health insurance. They provide what is called mutual funds. They provide with the different areas to be recognized while going for bank as employees. And going for example, in our organization, I have teaching and non-teaching employees, right? So employees pretty splitted. But how to represent in the ER diagram? I told only employee. There is not told anything, right? I told only employees, right? So employees various parts here. Employees principal, employees HODs, employees faculties, employees non-teaching. So if I go for again for any other factory, for example, we go for JK Tires, it is completely different representation. If I consider employees manager, employee section managers, employee supervisors, right? Different ways have been approaches. That's what the thing is. So now I want to go with representation of such a things as or consider bank as saving account, right? Fixed deposit, right? Current account, So various types of accounts for single accounts, right? That's what, it's very difficult task. So that's what you're going to, okay. So here I have accounts, I have accounts as a entity that is called superclass, that can be contains account number, that contains an account number, okay. So then I split this, with ISA, that is called the generalization, symbol worth like this, So this is a generalization symbol where accounts can be saving accounts, current account, fixed account, okay. So account can be fixed account, current account and savings account. Savings as some type of amount, saving amount, current amount, fixed amount, okay, fixed amount. So it has various attributes. So accounts as a superclass contain account number as a key. This is called generalization. We're splitting this entity. This was splitting this entity into subclasses. This superclass, okay, this superclass. So splitting into subclasses, where this is called saving accounts have some attribute. This is called current account have some attributes, okay. So here you have saving account has some attributes, current account have some attributes, fixed account have some attributes, okay. So this is superclass. We split it into 3 entities with different types of attributes, okay. When you go for representation through generalization, then you can tell that account with the saving accounts number as a table like this, with the account number as a superclass. This entity set, if I go for table of this entity, that is saving accounts as attribute saving amount, okay. When I go for representation of this, which is a divide of superclass, that is accounts with account number as a key, it's divided into 3 entities. So it has account, saving account, which is a subtype of account entity, as a saving amount. So if I go for table of this, so this is superclass contain account number and this contains saving amount. It will be look like this. This is the table that represents. It is a combination of superclass and subclass. This is a way of representation if I go for table in generalization. Generalization is nothing but superclass entity can be split into subclasses where there is necessary in a real-time application, such a way that the generalization comes, okay. So here next time if we go for this one, current account, then I will write current account table contains account number and current amount, and fixed amount that contains with account number, which account number as saving account, which account number as current account, which account number as fixed amount, right. So like this can we discuss in generalization, splitting entity into superclasses, okay. I will take another example that can be called as employees, So employees, if I write, as you told, employees SSN, okay, employees SSN is the key, then name. So here I have to be employees is told. If I go for small organization like us, we have 2 entity set. to be splitted. One is teaching staff. Other one is non-teaching staff. TA, what you call as non-teaching staff or teaching staff or a teaching staff of a employee we have okay. So employee as SSN as a key which unified employee and name. So employee entity can be substituted into teaching faculties and non-teaching staff, teaching staff and a non-teaching staff with SSN. Everybody has SSN. As an employee when you join for the organization, everybody need to have SSN with attribute name. Now I will go for teaching staff. What is the difference between non-teaching and teaching staff? Is first one is their salary. First one is their salary. So teaching salary. This one can be non-teaching salary, right? Non-teaching salary. So still you can divide. Maybe you can go with a part-time and a full-time. If you want to consider some private, means part-time employees, they're coming for weekly 3 days. Like this we can split it out. But I'm going with the generalization of teaching and non-teaching staff. You can split this employee into, because if you go to JK factory, there is a full-time faculty, full-time employees, and there is a part-time employees, where they comes with 3 hours or 4 hours work, but full-time employees need to stay entire day, right? So the salary will become different than consider for full-time and a part-time employees, and full-time and a part-time employees. That's what the employees generalization symbol with the teaching staff and non-teaching staff, where the first difference between is the salary. So salary is different and working hours will be same. That's what I don't want to include there. So that's what teaching staff and a non-teaching staff. This is called super class, that is employee. So it contains account number and a name. Now we split it into employees into subclasses, that is the teaching staff and a non-teaching staff. Teaching staff and a non-teaching staff, where teaching staff contains teaching salary, non-teaching staff contain non-teaching salary as a attribute. Okay. So now if I go for table, now if I go for a teaching table, teaching staff table contains account number, name and salary. Account number, name and a salary. Account number, name and a salary, right? So this is what it works. If I go for this is only one table, this one table which contains employee contains SSN and a name, that is one table of employee. Second table contains teaching staff with account number, name and salary. Next I go for the non-teaching staff, where it contains account number, name and a salary. Okay, got it? The differences arise in a salary way, that's all. But the employee's representation is different, right? When I go for ER diagram writing, teaching staff teaches subjects. Okay, so non-teaching staff handles the classrooms way of handling, right? So the representation go in a different way. If I go for employee teaching a students, I cannot write it, right? If I go for my organization and tell that employees works for department and employees manage students, I cannot tell like that. Employee has to be split, need to be splitted in any of the organization that required, where I tell that teaching staff go for teaching way, non-teaching staff goes for managing the classrooms, The relationship can be built in such a way. Okay, so relationship can be built in such a way. Okay, so like this we call as a generalization. This is a requirement of generalization while writing ER diagram. I was thinking how this works. Right? So if I go for bank has managers, again I want to split it out, like section managers, like attenders, everything you need to split it down. So like this, there's lot of way to analyze a generalization symbol as a generalization symbol. If I go for hospital, then maybe you find employees means doctors, right? Employees means nurse, employees means receptionist, employee means housekeeping, right? So these employees can be split, need to be splitted. It's not an easy way to tell that employees works for employees treat doctors, right? You cannot write employee treat doctors or employee treats patients, right? So required to maintain doctor treats patients, where the entity employee can be split into using generalization. You can split the employee, what I call as table to doctors, staff, housekeeping and receptionist what we have. So like this, the most use of generalization works in a database management system. Database management system. So this is called generalization. This is called an generalization. Then I'll go with the aggregation. I'll go with the aggregation. I'll go with aggregation. Okay, I'll go with aggregation. So one of the topic, the last topic in ER diagram. This is the last topic in ER diagram. Last topic in a ER diagram, that is aggregation. That is aggregation. That is aggregation. That is aggregation. You want to aggregate here. What is spitting out, but here you want to summarize. You want to summarize. You want to aggregate the entities and make one set and go for representation of a relationship. Then go for a representation of a relationship. Here I'll write employee. I'll write employee as SSN. Employee SSN and a name. Employee SSN with a name as a key and name as a attribute. Employee as relationship with projects. Relationship with projects. Relationship with projects. Relationship with the projects. Then I have relationship with machines. With the machines. With the machines to be identified. Machine as machine ID as a primary key, and you can tell that what type of machine is. What type of machine is. Project as project number and project name that contains. Okay, that contains. Okay, so now employee works on project. Employee works on project. In aggregation and generalization, there is no one to m, many to many, many to one. There is no Cardinality ratio can be applied for a generalization. Okay, and there is no apply for Turner relationship. We cannot apply the ratio for Turner relationship. We cannot apply for 3 entity type. We cannot apply for a ratio of 1 to 1, 1 to many, many to many, and many to 1. Okay. So employee uses, as I told previously, employee uses machine for project. Machine for project. So this is the way the representation we have an attribute called hours. So how many hours the employee is working on particular project. How many hours the employee is working on particular project. That is hours. Okay. Now we have two types of relationship. One is employee works on project. Other one is employee uses machine for project. Okay. Two types of relationship are represented. One is employee works on project. Another one is employee uses machine as a project, projects, right? So I need to maintain ternary. I maintain binary. I maintain ternary and a binary. So ternary is employee uses machines. Binary is where employee works on project. Employee works on project. So here employee works on project by using machines. Right? So I'm telling that. So employee works on project by using machines. So this is need to aggregate this. I need to aggregate where I tells that. So this part will be aggregated. This part will be aggregated. This part will be aggregated that both employee and projects uses machine. Right? Both employee and projects uses machine. Aggregated, I aggregated that employee works on project. So both are same, and aggregate this one, aggregate to one that both employee and projects uses machines. Based on number of hours. Right? Very small representation. See, this is what aggregation is. Aggregation tells that initially it was employee uses machines, employee works on project. So the employee tells that we are using a machine for projects, right? So I'm making aggregation that employee works on project, make it one aggregate that both employee and projects, both people are using machines for an implementation or a development or a developing a beautiful system, right? That's what aggregate employee works on project to one and tell that. So the both using machines for number of hours, both using machine for and number of hours. This is called aggregation, where I done aggregation of employee works on project. Both aggregation of employee works on project. So now if I write this, I can tell that aggregate this to 1, aggregate this to 1, okay, aggregate this to 1 with hours users machine. With hours users machine. We done the aggregation of this where I tell us that hours, number of hours, users machine, number of hours particular employees working on or a project is using for machines is based on number of hours, how we use, how to development system. So this is aggregation we done. We done a aggregation of a employee users or employee works on project. Employee works on project is aggregated to one where both the people can use the machines based on number of hours, based on number of hours. This is the way of representation of aggregation. It's the way of representation of aggregation. So here we comes with an end to ER diagram explanation. We come to explanation of ER diagram end. Okay, so this is the topics. This is what we done with the entity attributes, relationship, constants, participant constant, total participant constant, ratios. Then we comes with recursive, weak entity. Then it comes with a generalization. Then it come with the aggregation. Everything is utilized to develop a beautiful ER diagram for any real-time application. You want to utilize all this and go for developing a beautiful ER diagram. A beautiful ER diagram. So thank you. So in next class, I will teach you peoples how to write an ER diagram. Thank you so much.